Hey everyone, welcome to this Markforged webinar. Today we're here with Phil Vickery, who is the president of Centerline Engineered Solutions in South Carolina. Today we're going to be talking to him a bit about how he bought a 3D printer and how he's been using it since he's gotten it and what he thinks about Markforged and the industry in general. With that, Phil, can you kick it off and just introduce yourself?
Sure. I've been at Centerline Engineered for the company has been here for about 25 to 30 years actually. We trace our histories back to the textile industry, supplying into that industry, and over time we have expanded into other industries. Primarily now we service the electrical industry, consumer products, and also the wiring industry. So that's kind of our basis of our company here. We've got about 25 employees, and we service most of the industries in across North Carolina, South Carolina, Florida. So kind of southeast is where most of our clients are. My personal background, I'm from South Carolina. I graduated from Clemson University. I'm an electrical engineer by background, and came to Centerline Engineered Solutions about a year ago, and am having a wonderful time here.
And so, when you say you kind of support these industries, what do you do to support them? Do you make parts? Do you kind of support their processes? What are you doing there?
We do a multitude of things for certain customers and clients. We supply parts to their finished assemblies. So we are making a finished product that goes straight to their customers. For some of our other clients, we make and engineer parts and even equipment for them. So when they have a rebuild of a major piece of equipment, we will assist in that process. We build custom equipment to meet their specifications they can't buy off the market. And to do that, we use all types of different machining and fabrication techniques that are required in order to meet this diverse background or customer base that we have.
Awesome. And so, what kind of machining capabilities do you guys have in house?
We have CNC milling centers. We have CNC lathes. We have an assortment of manual milling and lathe operations. We have laser cutter. We have press brake. We have welding capabilities. We partner with other customers or other partners for powder coating and different electrical coatings that are required into the industries in which we serve.
Cool. And so you got into 3D printing as kind of an add-on to your fabrication capabilities pretty recently, right?
That's exactly right. So we purchased our 3D printer in December of 2017, and since then we've introduced it to most all of our customers, and have found that most of them have been very intrigued by the opportunities that it presents. There's a tremendous amount of information out today about additive manufacturing and 3D printing. Almost every trade magazine today has an article about 3D printing capabilities in some form or fashion. So there's a lot of interest that I'm finding from my customer base throughout in what can it do for me and how can it be utilized.
Awesome. So before you bought this printer, what were your kind of preconceptions? What did you think about 3D printing?
That it was good for prototyping, and that it was used more so to make neat objects that you can use around the house almost. Because when my customers and friends who had 3D printers, that's kind of what they utilize the technology for.
Yeah.
But when I started really looking into making a purchase, I was very interested in metal, 3D printing of metal. And there's as we know in the world, there's a lot of big companies who invested millions and millions of dollars developing this technology. It's coming in the future, and we know it's going to be there. So my first research began more in where are we in the development of 3D printing for metal. And in that, I researched and found Markforged and saw where they were at in their progression from the beginning first steps of 3D printing with with onyx and the other carbon fiber and Kevlar and fiberglass, all the way up to getting close to introducing a metal 3D printer. So that was intriguing that I had a supplier who could take me throughout the whole continuum.
Yeah.
So I started doing the research, and that's kind of what led me to Markforged. And when I looked at other vendors and other opportunities there, I didn't see the same type of specific path.
Yeah. And so you ended up buying a Mark II in December of last year, so about 5 or 6 months ago. What were your kind of first impressions of it when you got the machine, when you kind of first started printing composite parts?
My first impression was it was very robust. It was elegant. I guess it's a good way to use it. I have, within the first 2 hours of it arriving, I was printing things and really learning about how 3D printing really worked.
Yeah.
So it was a very easy startup from my standpoint, and it's been well accepted by my employees as well.
Mm-hmm. So you mentioned that originally you kind of viewed 3D printing as prototypes and that kind of stuff, but on the table in front of us we see a whole ton of tools and fixtures. How did you kind of make that transition from the conception of the prototypes to actually making all these tools and fixtures?
You basically do it by dreaming a little bit. I guess is probably the best way to say that, and challenging also how we do things. With a fabrication and engineering shop like myself, we're constantly looking for the most efficient way to do our jobs faster and more accurate. Because being precise is something that all of our customers demand, that precision in everything that we do. So we're looking for tools and fixtures that help us to be more precise and efficient. And in doing that, in shops like what we have here, for many years, the traditional way was to make a fixture was out of metal, which required a machinist who was very technical to make something in order to make something else, which is very inefficient. So now I can take a CAD drawing and draw something and print it out and say, here's the fixture within half the time it took to make it in the previous methods.
So I guess with that kind of understanding of how you got into tools and fixtures, I wanted to jump into a few of the parts that you guys have here that you've been working on. So the first one is this press brake punch that you have that I've seen around on the web a little bit. Can you tell me a bit about the part and kind of how it came to be printed and how you came to think about fabricating it with a Markforged machine?
Okay, so it came to us as a drawing from one of our customers. They said we need this part to be made, and we only need I think 2. Okay, so to make something that to buy a special or to make a special die for a press brake, it's very expensive. We're talking $1,000 to $2,000 depending on the complexity, and something like this it'd have been around $1,000 is what we thought. So the customer was not interested in investing in that for 2 parts. So we started thinking and looking, and with the way the Markforged printer works, its ability to stop while it's printing and for us to insert items into the printed material was very intriguing from the very beginning. So we did some experimentation, and we found that we could add some metal to the print, which would give us more confidence that we could actually make a punch with onyx, which is basically the plastic material. So that's kind of what led us to the thought process, and then we did some prototypes, and lo and behold, we were able to make a punch that was successful in making this part to the customer's specifications. So really it came from the standpoint of the customer only wanting a limited number of parts with this design, and us just trying to find a creative, cost-efficient solution.
Yeah, it's interesting. I've been at Markforged for a while, and I certainly wouldn't have expected that our parts were capable of punching out steel. So with that, can you talk a little bit more about the role the inserts played there, and kind of why you put the inserts in, and in particular how it kind of helps these printed parts accomplish the goal.
Okay. Well, the inserts basically you put them into the design, and you basically have you print a cavity within your print, or design a cavity within your print build, and then you just program the printer to stop, and then you of course take it out and put your specifically designed or piece of metal into that. And what that does is, as the press brake applies pressure, you at least you know there's going to be a certain amount of rigidity to your press brake and to the mold, to the punch, and to the die as part of it. You know, there's I don't expect this type of technology to replace metal dies at all for the press brake. But when you're looking at forming applications where you're not making a 90-degree bend, but you're making a small bend or insertion into metal, we've shown and have confidence that you can print a die that can, with a Markforged printer, that can successfully form the metal.
Yeah. And so what do you think kind of like the larger term implications of that? What did your customer think when you're able to come back with this much cheaper punch and die set and give them the part they wanted?
Well, the customer, when we talked to them, they said they had no idea how we were going to ever make this part. And they were surprised that we came up with a cost-efficient solution. So it gave us, it gave the customer more confidence in us as a supplier, which is also very important to me. But once we were able to do that, and also to show to our employees, and that's part of this evolution that we see, is that our employees start coming up with even more creative applications for printed parts when they see what you can really do with them. And we can see we can make parts and we can form parts, and it's easier to print a part than it is to get someone to, many times, than to get someone to make it out of metal.
Absolutely. That's such an interesting application. It's one that I certainly was swept off my feet by it. So moving on a little bit, I wanted to talk about this roller that you have here. Can you talk about about like how this roller came to be and what it does, and why you thought about printing it originally?
Okay, so this is an application where one of our customers that manufactures wire in the electrical industry, they use rollers kind of throughout their facility to redirect wire, which is made of metal, and it's continuously moving high speeds throughout a 24/7 operation. And they utilized rollers at many different points, but this one specific one, they have almost 100 rollers there together. But the design that they had was made up of 3 different pieces, and each one of those pieces had to be specifically machined. They weren't off the shelf, which means they were expensive. So you had 3 different pieces that came together in one assembly. And so once we saw that there was 3 pieces together, and we saw what the application was, we had the idea of, that it's possible that a 3D printed part could supplant this current design. There was some questions about how durable and how robust it would be, but thus far we have still 5 or 6 of the rollers that are in place and still operational. And that's been at least 2 months or so of operation.
So this rolling system, you said there's 100 in series. What they're doing is basically bending this wire around. So I can imagine there's a lot of rub on the rollers themselves, right?
Absolutely. There's a lot of tension on the rollers because you're basically coming in and you're doing like either a 45 or a 90 angle that the rollers are redirecting the wire. So there's almost a constant force that's applied. So when we looked at different applications, and really this is where the Markforged material, I think, gives us an advantage, because it is very strong and durable, and it's getting the tensile strength is much stronger than what I found in other printed products, and I think that's what allowed this to be a successful application for us.
Awesome. And so these original parts, these 3 parts, it was something that had a lot of different machining operations, right? And so
Yep.
You mentioned before maybe that something that's complex to machine is better to print. Can you elaborate on that?
Absolutely. So in most machine shops, you have your different types of operations, and anytime you have a piece that hits 3 or 4 different operations, 3 or 4 different skill sets, 3 or 4 different people, it gets more costly each and every time it touches another person in another operation, because you got setup time and you've got machining time and things of that nature. And that's where I've seen a real benefit and opportunity for 3D printed parts, is where you have parts, whether they're finished parts that go to our end customer, or if it's just a part that goes on a piece of equipment or machinery that our customers utilize in their operation. If it requires multiple machine operations, then there's costs that can be taken out by 3D printed parts. And then that's also, as you look forward into the future, the labor force, finding people with these skill sets to machining and things, it's getting more and more challenging. So to me, that also says that in the future, there's going to be a lot more opportunity for 3D printed parts because of the complexity that some of these parts currently have.
Very cool. And so all in, how much money do you think you saved on this, or how much money do you think you were able to save the customer on these roller sets as of like per roller basis?
I estimate about 60%.
Cool. So I guess moving on, we had one more part we wanted to look at today. It's kind of a gauge inspection fixture. Can you kind of talk us through what we're looking at now?
Sure. So we utilize the gauges and fixtures in our quality assurance area to and on the setup of our equipment. So anytime we're setting up a new part, we're always working to a blueprint that has dimensional tolerances, and a lot of what we have are different angles and different pieces that require very precise locations, because they're part of an assembly. And it's a big challenge when you go from one piece of equipment, one setup to another setup. And anything we can do to help have a faster setup, we're cutting our cost out. And what we have found is that if we print fixtures that basically can quickly verify that the setup is correct. So we're basically able to, for example, to verify an angle that is in a part, to verify the hole location, to verify the size of a hole or something of that nature. That's where it's easy for us to print a fixture. It's easy for the colleague who's setting the equipment up to say, yes, I'm there, this meets the tolerances, or not. Where in the past that we would have to take this part, we'd have to go to a QC area and oftentimes have to make a setup just to test the piece in the first place. Where now we can basically use this fixture and within a matter of seconds have an answer of this part is made correctly.
Yeah. And so I guess one challenge, it's an amazing increase in kind of efficiency, but one challenge I can imagine is that since you're looking at this as a QC fixture, it's got to stay accurate over a period of time. So how have you found the Markforged printed materials to kind of maintain their accuracy and durability for something that's this precise?
From a accuracy and durability standpoint, I've found that the items that I've 3D printed have maintained their precision. I haven't seen any concerns or any issues with that. The reliability and also in abrasive type situations, the material has held up quite well. So I'm not as concerned about that at all. I'm more concerned about my customers changing to a new addition or a new blueprint or revision and updating from there. That's more of a concern.
But I guess that kind of uncovers another advantage, is if they update their drawings, you just have to print out a new thing.
Absolutely. I just come and I print a new fixture and bam, I've got that.
That's awesome. And so all in, what do you think kind of the business impact is? This is kind of a different one from like a cost saving perspective, because it's different. It kind of invented a new process here. Yep. But if you were to guess, what kind of business impact are you looking at?
I would say for many of my setups, it can easily save me 20 to 30 minutes on a setup and first part type testing. So 20 to 30 minutes of setup, and we do setups every day and sometimes multiple per day. So
Yeah.
it's I'm saving several hours a week.
That's awesome. And every hour in a machine shop is obviously valuable because it's
Absolutely.
all about the bottom line.
Absolutely.
So yeah, these parts are awesome. Before we kind of finish up and kick it to questions, I just wanted to kick it to a few kind of higher level things about Markforged and printing in general. So I guess the first one is, how do you think using these printed tools and fixtures kind of altered your manufacturing workflow as all? It's like, for example, like when you get a job, does it change how you thought about how you're doing it?
Absolutely. It changes. The first question that we ask when we get a quote, request for quote, or a PO that comes in is, how can we do this more efficiently? Is there something that can be printed that can help us get this part made faster and better? And that's a question that we have now asked at the very beginning. And the other thing that is really encouraging is the employees on the floor, the machinists and others who were very skeptical of 3D printed parts in the beginning. They now see the value of how they can utilize these parts to make their jobs more efficient and more effective.
Yeah, and so how is that kind of extra buy-in from the employees kind of bolstered the use of the machine overall?
It's helped tremendously because it's frequently that they're asking, can you print this to help me do this, or it's something of that nature. So it really makes it much easier to be creative with some of our applications.
Yeah. And so with that, how do you kind of expect the printing and kind of Markforged to kind of grow in your operation over the next few years? What are some things you think you haven't done yet that you'd like to do a bit more of, or some things you'd like to sell more of in general?
Yeah, I think there's many things that I would like to continue to do because from a quality standpoint, quality's always got to be foremost in any business to our customers. If you're not making quality products, you're not going to be in business. So to continue to utilize fixtures and jigs to help us from a quality standpoint is something I absolutely want to do. Also, I want us to continue to make parts that my customers use in their industrial applications, because I believe there's many opportunities within my customers that I see where they're using more expensive metal parts that could be 3D printed at half the cost. Mm-hmm. And I can pass that savings on to them.
That's awesome. It's good to hear. And the last question before we kind of kick it to questions from the audience is, what's your advice to engineers and manufacturers who are kind of thinking about adding to their workflow, like the average job shop? What would you kind of tell them?
I tell them to be open-minded about 3D printing. With the Markforged technology, I'm finding that the material is much stronger than I ever expected, and it holds up over time. It's not going to replace metal anytime soon with the current technology, but Markforged is also on a path to have a Metal X technology coming in the near future, and that'll open up even more doors. But we know that 3D printing is going to be a major part of the future, and even if we're not printing metal, I think every fabrication shop it'd be in their best interest to begin learning about 3D printing, even if it's based on onyx or some type of plastic, because that's going to be a part of our future.
Awesome. Phil, thank you so much for your time, and with that, we're going to kick it to questions.